Alright students, so in this video we are looking at more exponential functions and primarily focusing on y is equal to e to the x. Now e by itself, e to the first degree is always equal to 2.71. So when I have it in this format, y is equal to the e to the x, or y is equal to e to the x, I can make a table to find some values that will generate some points, and the easiest one to always select is 0 for x. If x is 0, e to the 0 is always 1. So my y-intercept is 0, 1, which is right about here. The next point that I can select could be 1, and I know that anything to the 0 is 1, anything to the first degree, so e to the first degree is of course 2.71. So when I plot that on the graph, I will have, so x is 1, y is about 271. And if I select, let's say, 2 more points, if I do -1, it's going to be e to the -1, which we know it's 1 over e, which is about 1 over 2.71, and that's roughly about 1/3. So I can say it's about 1/3, or you can leave it as 1 over 2.71, but when I graph it, you know it's going to be roughly about 1/3. So -1 and 1/3 right about there. Anyways, so this on the left, as x approaches -infinity, it approaches 0, and as x approaches infinity, y is approaching infinity as well. So my domain here, will be all real numbers. Range will be y is greater than 0. The asymptote is y equals 0. Okay, so that's basically the graph of e to the x. Now if I had a function that equal to, let's say, -2e to the x plus 1, what does that mean? Well, just like the other transformations, we know that if the number on the outside is negative, that means we have a reflection on the x-axis. And if the number on the outside is between 0 and 1, we know it's a vertical compression. But if it's more than 1, then we have a vertical stretch. Now notice how I have this right here is x plus 1. That means that this is shifted. It's shifted, and I should have started with that. It's shifted to the left 1 unit. So shifted to the left 1 unit. So all this right here, if I were to shift to the left, then it would be something like this. Shifted to the left 1 unit, and then a vertical reflection, or vertical stretch and reflection on the x-axis. It will be something like this. So this will be the new graph. This graph here represents this graph. And so if you think about the domain is still going to be all real numbers. Range still will be, well, in this case it's going to be less than 0. with an asymptote of y equals 0. That did not change. Y equals 0. Alright guys, I hope this makes sense. Sometimes if I have an equation like this, it might be asking for the rate of change. So let's erase all this and all this. And let's do another equation. In fact, let's do the same one. Let's do f of x equals negative 2 e to the x plus 1. But this time I want the rate of change from, let's say, negative 1 to 0. Okay, I want the rate of change from negative 1 to 0. And rate of change, what it means is just slope. That's what it means, slope. So quickly I'm going to find the values of y when x is 0 and when x is 1 using the same equation here. So if x is negative 1, well, negative 1 plus 1 is 0. E to the 0 is 1 times 2, well, that becomes 2. If x is 0, e to the 1 is 71 times negative 2, that's negative 5.4, give or take. Oh, and by the way, this is negative. That's negative. So I want to know the rate of change between negative 1 and negative 4. Remember, the slope formula is y minus y over x minus x. So I have negative 2 minus negative 5.4. Divide that by negative 1 minus 0. And so we end up with, this becomes positive. So you have 3.4 divided by negative 1, and the answer is going to be negative 3.4. So between negative 1 and 0, that graph that we had earlier today, this graph right here, this graph, between negative 1 and 0, so negative 1, between negative 1 and 0, this actually goes down more like this. But between these 2 points, we know it's decreasing at a rate of negative 3.4 for each unit. So that would be your slope between negative 1 and 0. So that would be the answer. So rate of change, again, means slope between negative 1 and 0. We found the values of y when x is 0, when x is y. Please let me know if you have any questions. We'll see you very, very soon.